Hello guys and welcome to Dura Data. So we are a specializing entity that deals with data. Our aim is to transform the raw data into actionable insights that can help our businesses. So in this video, we are going to talk about the a priori algorithm, which is one fundamental principle that is actually used when we are analyzing a client's data in terms of their purchasing behavior and the buying patterns for its clients. So the a priori algorithm actually helps us to identify those goods that we should continuously restock or also apply different business decisions. So in this short video, I'm actually going to take you through some of the fundamentals that you're supposed to implement or when you want to analyze the products that you sell as an entity, be it services, you can equally apply these principles. Um, I'll leave this demonstration in the link down below. So support us guys by liking and subscribing to our videos. We hope to load more as we transverse within this data analytics journey. So you can add in the comment sections below something that you would also want us to simplify and make a video along those lines. So the a priori algorithm is actually a classic method for actually mining. What we are saying, it's a classic method for mining association rules from the transactional data set. In this scenario, we're going to just implement a small data set from which we will do our analysis. But our end goal is to discover the frequent item sets or collection of items that appear together frequently and derive association rules based on that. For example, we are saying if a customer buys bread, what is their likelihood that they will buy butter in a supermarket? So some of the key concepts that we will talk about or that will illustrate in this video include the support, confidence, and lift. So support is how frequent an item set appears within the data set. And then confidence is how often items in Y appear in transactions that contain X. Then the lift ratio is ratio of observed support to that expected. Let me just quickly correct this. So it's expected if Y and X were interdependent actually. So I'll just quickly run through. You can run the first and foremost step. So I'm using a Jupyter notebook here in this instance. So you just install the requisite libraries that we'll be using for analysis. So in this instance, we're using pandas and the ML extend libraries. So you can run, install. On my end, I will not run this because I have already installed these libraries. So the next step for you is to actually do the importation of those libraries. So I've actually prepared the whole solution. I'll walk you through and explain each and every part until we get to what you can transform into a real world application within your dataset. But we are here to help you. You can reach out in the comments or in the contact details given in this video. So we run this is general importation of our libraries that we're going to be utilizing. Then I'm going to prepare a simple dataset so that you can understand what the a priori algorithm actually does on your data set. So this can then translate into a bigger data set that would have gone obviously through the data cleaning steps, which I'm not covering in this video. So I'll name my dataset. So if you know from your Python, we just creating a list from which we then create a data frame. So basically, we are saying for each observation, we're creating a certain combination of goods within that list. So our first customer in this instance will buy bread and milk. Our next customer buys second observation up to the fifth customer. So basically, these are the small products that we would want to analyze using the a priori algorithm. So I'll run this. It brings about an output of a list within a list. So this is our observation that we'll be dealing with in this um, video. So the next step is actually converting that list into a data frame. So for those of you that are new to Python, it's a structure, a data structure that is actually easy to work with within this environment. So this is what we do. I'm going to copy the next code. So we are saying we convert the dataset that we have actually inputted of that we have created into a data frame. So we use the pd dot data frame object to change it into a data frame, and you see the result. It's now readable, more clearer. So each observation is actually one object, and starting at index 0 up to 4, we have 5 records. So as you can see, we have got bread, milk, and none, none, because we had bread and milk in our first transaction. Then the next thing is actually transforming this data set into a matrix that will be readable and applicable into our association rules, as you see when we apply those rules so that we can analyze the data. Because remember, computers do work with ones and zeros, so we need to apply a transformation step where we actually transforming these um, products into a different matrix, but which I will explain after running the code below. So from MLX extend dot processing, we importing the transaction encoder. So remember, we've got different types of encoding that we can do. One hot encoding being one of them. So we transaction encoder is what we are applying to our data set, and you see how the result comes about. So we first of all initialize the transaction encoder, then we apply that transaction encoder to our dataset, and we transform the same dataset. So I'll run this query. So here we can now see the transformation that has been done by this function. So what we are simply saying, we have now taken all the products that are within the dataset, put them as the columns, as you can see. Then for each transaction corresponding to what we had initially in our um, index 0 or in our dataset, you can see that beer, we have false, true, false, true, to say in our first transaction there was a beer and bread. That way, there was bread and milk that were purchased. As we can see from this first transaction, we only had bread and milk that were purchased. The second transaction goes the same way. So where the transaction identifies a certain product that has been purchased with that customer, it returns a true. From this, we are then able to apply our a priori algorithm to say we want to find the frequent sets. That will be your next step. Let me take this. So in this step, what we are simply saying is, let's apply the a priori to our dataset, this DF that we have. Then we have the minimum support, which is 0.6. I'll talk about these metrics as I've highlighted in our opening of this video. Then we use columns as true, which are saying return columns as true. If we run this, so in this instance, we are saying beer has got a support value of 0.6. Remember, when we go up, we are saying support is the frequency of an item set within the data set. So we are saying for each transaction, do we have a purchase of that product? We count it as one occurrence. So in this instance, I'll explain with this beer. In our first transaction, we do not have beer. In our second transaction, we do have beer, which is 1. Second transaction, we have got beer, 2. Then the third transaction, we also have got beer, which is true. Then in our last transaction, there is no beer. So out of the 5 transactions, we've got 1, 2, 3. 3 divided by 3 over 5 times 100 gives us 60%. The same goes for bread. We've got bread in our first transaction, bread again in our next transaction, bread again in our fourth transaction, bread again in our last transaction. So we've got 4 out of 5 times occurrence where bread was actually bought by our client. This gives us a support of 0.8. The same goes for diaper and beer. So we want to find where diaper and beer are supposed to be true. So when we go to diaper and beer, we can count that when beer was bought, also diaper was bought in that transaction. When beer was bought again, we also have a transaction of beer. And when another beer was bought in another transaction, there was also another occurrence of diaper. So this gives us 3 occurrences out of 5. This is why it's giving us a 6. So that happens to all the transactions. So you could have a million of transactions that you want to analyze. You can do the same. So you could change the minimum support to say we want to see where the support is actually 50%. If you run this again, you see that it changes slightly. So if we also have another one, let's say where we're saying 10%, you see that the list now is larger. We are saying we have actually gone to take 20%, 20%, 20%. But for this demonstration purposes, we'll maintain it at 60% for simplicity so that you clearly understand. But I wanted to highlight that to you. So the next process is actually applying the a priori, the association rules to our dataset. And which dataset? We are now using the frequent item sets to say, let us apply the association rules to what we have identified as our frequent item sets. So we are saying these products, can we use a matrix of confidence using what threshold? 0.7. We are saying where there is 0.7 chance that if one product is picked, the other one will be picked. Let us apply that metric. We're using the 70% threshold. And we run this. So it retains the new rules, but we want to print and see and visualize the rules that we are getting from our application of the association rules for the products that we would want to analyze. So let's take the last part. Then we run this. So this is where you have your output for those products that we want to analyze. So in this output, we are saying this is the root node. If diaper is bought, there is a chance we also buy beer. I explained the support. So we are saying the confidence of or the chance of buying beer after having bought a diaper is 75%. The same goes for all these other attributes. But you can see from here, one would ask, if one picks beer, there is 100% certainty within our data set that they will also pick a diaper. So you might get a bit of confused here, but I will explain using this data set. So we have beer. If a person buys beer, if a person buys beer, it's absolutely true that they are going to buy a diaper, as you can see in these records. If a person buys beer, there's an absolute chance that they will buy a diaper. However, the reverse is not true. In one instance, the last incident, a person bought diaper but did not buy beer. So for this small data set, this is the explanation of our confidence. Then for the lift, I will leave and explain the notes that follow. So the lift definition, I had given it on top, but I will explain it further. So we're saying the definition of lift is a measure that evaluates how much more likely the occurrence of the right hand side, which is in this instance the antecedents of a row given the left hand side compared to the right hand side occurring independently. So mathematically we are saying it compares the observed frequency of both items appearing together to the frequency expected if they were statistically independent. So there is a bit of probability that we apply here. So we are saying, given row A leads to B, where A, like I said, is the left hand side and B is our right hand side, we apply a probability rule, which I will explain in the notes and leave it for you to work out, but it's not absolutely necessary. What we need to understand is that the lift is crucial in a priori based association rule mining because it filters out rules that may have high support confidence but no real correlation ship. So we are saying if the lift is over 1.5, there is a higher chance that those two products will be bought together. The lower it is from 1, then the less likely that product will be bought together. So I will leave this paper with you guys in the comments below. You can add and we can help each other to do further analysis. But this is a high level understanding of the a priori algorithm. You could probably use it and adopt it in any setup that you want to apply in your business facet. Thank you.